Law of cosines applies to all triangles. It's a generalization of the Pythagorean theorem, but Pythagorean theorem applies only to right triangles. Now, law of cosines can be used in any triangle. And before we state it, we need to get the notation correct. So this is how we will draw our triangle ABC. So say this is ABC. If I'm using these labels for those vertices, then the side opposite to A is going to be denoted by lowercase a, and this would be lowercase b, and that would be lowercase c. And actually, I did not write here anything because what I intend to do is draw an altitude from A. So I'm going to split the side A. So if this is altitude A, let's call it has height h. And if this, and let's also label the point of intersection as D. So if this is x, then the total is A, so this has to be A minus x. And notice ABD and ADC are right triangles. So we can use Pythagorean theorem. So let's write down from triangle ABD, we have c square equals h square plus x square. So call it equation 1. And then look at the other right triangle. From triangle ADC, you get b square equals h square plus a minus x quantity square, because these are the legs, h and a minus x. And if you expand this side, h square, now how do you expand square of a binomial? Well, there are three terms. The first term is a square. The middle term, if you have a minus here, you would have a minus 2ax. And then the last term is going to be plus x square. All right, so this is our b square. But notice, there are these two terms, h square plus x square. I can rewrite this as, so I can combine these two and call it c square. So this is going to be c square plus a square minus 2ax. So let's rewrite our b square is c square plus a square minus 2a. All right, let's go ahead and write x, but I intend to change x to something in terms of ABC. And notice, again from triangle ABD, I know this angle is B. So from triangle ABD, if you look for cos B, that's going to be x over c. Now, why did I choose cos B? Because this angle is, I don't know what it is because it's not A. A was the total angle. This is something other than A. But this one I know is B. And also, I needed x, and I know that this side length is c. So this is, if I multiply both sides by, oh, this should be lowercase c. So let me write it a little bit smaller. So that means x is equal to c cos b. So c cos b. So let's go ahead and replace this x with c cos b. So b square equals c square plus a square minus 2a, and then this is c cos b. So this is the law of cosines. What I'm going to do is, on a separate sheet of paper, I'm going to copy this first. B square equals c square plus a square minus 2ac cos b. B square equals c square plus a square minus 2ac cos b. Now, if you relabel all these vertices, then you can get two other equations. So here is what we want to pay attention to. If you want b square, then you'll be squaring the other two sides, which is c square plus a square, and then you will subtract 2 times the product of those two sides, AC, the other two sides. And then you take cosine of the included angle B. So let's write down a square then. What is a square going to be? Well, a square would be b square plus c square, sum of the squares of the other two sides, minus 2 times the product of BC, and then it would be cosine of angle A. You can see here, this factor has lowercase a, lowercase c, and uppercase b. So you have all those three letters A, B, C, and that's what you would have here. And c square would then be a square plus b square minus 2ab cosine c. This is the law of cosines. Now, why is it the generalization of Pythagorean theorem? In a Pythagorean theorem, what happens is we have just c square equals a square plus b square. Why? Because there cosine c would be 0 because c is 90 degrees. Pythagorean theorem applies only to right triangles. So if you have cosine c equal to 0, this is still true. You get c square equals a square plus b square.